Hello, I'm Bo Weidema. This is the 7th video in a series of 10 on consequential modeling in lifecycle inventory analysis. This 7th video is about the linking algorithm, how to compose a consumption mix. That is, how do we link the different unit processes in a lifecycle together so that they represent a product system. So what do the standards have to say about this? Well, unfortunately, the guidance is not very easy to find. In ISO 14044 on lifecycle inventory analysis, the standard references ISO Technical Report 14049, Clause 6.4. And in that, the following guidance can be found, which is by ISO 14044 Amendment to 2020, called the identification of the upstream system for intermediate product inputs. The actual text in ISO 14049 talks about the supplementary processes to be added to the systems as being those that would actually be involved when switching between the analyzed systems. That is pretty obvious. But additionally, several pieces of information are necessary. First of all, in the bullet number 1, the ISO 14049 talks about the production volume of the product systems fluctuating in time. That is what we discussed in the previous video on the topic of temporal markets, where we can have peak loads and base loads. And in the case of a base load market, the ISO 14049 goes on to talk about that in this case, the base load marginal is the applicable. In bullet 2, ISO 14049 goes on to talk about deliveries through an open market, where it's necessary also to know whether any of the processes or technologies supplying the market are constrained. If they're constrained, they are not applicable, since their output will not change in spite of changes in demand. And in the last bullet of 14049, clause 6.4, it is described what happens within that group of unconstrained suppliers or technologies that can actually change and supply the product system. There, it is important to know which one has the highest or lowest production costs. So is the more or less competitive. And there, this is described as the marginal supplier or marginal technology, when the demand for the supplementary product is generally decreasing or increasing, respectively. That means that when you have a high production cost, so a low competitiveness, then that is the one which is relevant in a decreasing market. In an increasing market, the one with the lowest production costs, so the most competitive, is the relevant one. This is what we apply in our linking algorithm. To identify the marginal unconstrained suppliers, we look at the modern competitive suppliers when the product demand is generally increasing, and we look at old uncompetitive suppliers when the product demand is generally decreasing. This is basically what ISO 14049 says. However, there is an important addition to this, namely that this difference between increasing and decreasing must be seen relative to the replacement rate of capital. Now, what do I mean by that? We can illustrate that with this graph, where time is out of the x-axis and the production volume out of the y-axis. The production volume is also basically the requirement for production capacity. So if we say that we have a situation where the production volume is constant over time, in that situation, whenever you're above this line, modern technology would be affected. And even if you are on the line, then new capacity would still be needed, simply because technologies will deteriorate over time, so we will need more capacity just to maintain the existing production volume. And that is actually the case whenever you are above the capital replacement rate. If, for example, we say we have a capital replacement rate of a 30-year, or rather a lifetime of your capital of 30 years, then the capital replacement rate per year will be 3.33%. So whenever your technology or your demand for the product, the production volume, is above minus 3.33% annually, you will still need to install additional new technology. Only when you're below this capital replacement rate, then you will affect the old technology, which is the one that will be taken out of the market. An example of this is natural gas, which has a 30 years lifetime in Denmark. Currently in Denmark it has a trend of minus 2.3% per year. So we're using less and less gas, but we're not using gas at a lower rate, at a lower trend than minus 3.33, which corresponds to the 30 years lifetime. So we would still need in Denmark to install modern technology for maintaining our demand for natural gas. In the linking algorithm, we are here having always a demand put on a market. So whenever we are asking for a product, we are asking for a combination of inputs from different technologies, those that supply the market. These can be composed of those which are old, current, modern, and even some that are just byproducts of some other technology. Now, byproducts will always be constrained because their determining product is what determines how much you will have of the byproducts as well. So byproducts can never be affected by a change in demand, and therefore they are excluded from our consequential market mix. Then we can go on to look at an increasing market trend where we also will exclude the old and the current technologies, because essentially we're only looking at the things that change, and that is the most competitive technology, the modern one. And here modern is used as a synonym for what is installed when you're increasing capacity. That means that all the inputs to the market will come from this technology and not from the old and the current. You can also have a situation where the market is sharply decreasing, and then the old technology is what comes into play, being decommissioned, being the least competitive, and therefore the one affected when the demand changes. You can also have a situation where the entire market is constrained. None of the suppliers are able to react. But what happens then? When we have a demand, we need to fulfill that demand. So we fulfill it by somebody else giving up their supply. This is called the marginal consumer. Now, an example here is where you have a byproduct as the only supply to the market. Since byproducts are constrained, in this case sodium hydroxide, it's always a byproduct of chlorine. So when you ask for more sodium hydroxide, you cannot get any more because it's already used by other users. The chlorine production will not increase because of this demand, because chlorine is what determines the total production output of both chlorine and sodium hydroxide. So therefore, we need a consumer to give up something else. And that is a user that is able to substitute the sodium hydroxide with another neutralizing agent. In most cases, this will be soda. So because they have soda has a slightly less neutralizing capacity than sodium hydroxide, you need to use more soda when you're decreasing your input of sodium hydroxide. So the marginal consumer of neutralizing agents will liberate this 1 kilogram of sodium hydroxide that I have asked for as a consumer, and the marginal consumer will then instead use 1.325 kilogram of soda. In both cases, the marginal consumer gets the same service, namely a certain amount of neutralizing power, while the people who need the sodium hydroxide for other things than neutralizing agents will get that 1 kilogram that they're demanding, without affecting the upstream chlorine or any other supplying technology. One could also argue that it is the marginal consumer that becomes, in a way, the supplying technology in this case. It's possible to have a supply which is only partially constrained, so that some of the supply will come from a normal supplier, while the rest will come from a reduction in a consuming activity. This is normal in short-term economic models, but in lifecycle inventory modeling, it only occurs when there is more than one determining product that does not have an alternative production route. We will come back to this later. So how is all of this implemented in Ecoinvent version 3? Well, first of all, the technology constraints are introduced in forms of a classification. We can call a technology outdated, old, current, modern, and new. So basically 5 options. And this is done by the individual data providers of a data set, thereby signaling whether the activity should be part of the consequential consumption mix or not. This makes the determination subject to peer review and scientific dialogue. For constrained markets, when there are no unconstrained suppliers to a market, this is modeled as a reduction in consumption of the marginal consumer, just as we've just seen the example of sodium hydroxide. And finally, the byproduct constraints. There we have a rule saying that only reference products, that is determining products, can be unconstrained and thus part of the consumption mix. So byproducts are consistently not included in the consequential mix. So the Ecoinvent version 3 actually follows the consequential rules that we've just described here quite consistently. Regarding the first bullet about the byproducts, you can see that it is quite crucial whether a product is a determining product or a byproduct. And to be sure that we identify this correctly, we have a separate routine that I will discuss in the following video. Thanks for your attention.